I was noticing that there are a lot of products in the market where they have gold nanoparticles. So I was kind of curious, what do they do to the skin? So I found some researchers who actually did a study, and there have actually been quite a few, but I chose this one. And they did a study, and they wanted to find out the long-term effects of gold nanoparticles in skin cells, because the studies before only went over about 2 or 12 hours, and they decided they wanted to do the experiment over a few days. And they wanted to make recommendations regarding gold nanoparticles safety as a potential hazardous material in the laboratory and in general use. All right, so they used 2 sizes of gold nanoparticles for the experiment. They used 13 nanometers and 45 nanometer sized gold nanoparticles, and they did it over. They used skin cells, and they actually put them in a solution of the gold nanoparticles, and they did it over 3-day and a 6-day period, and 6 days later they used an SEM to observe the results to see what happened to the skin cells, right? And what they found was actually really interesting. They found the gold nanoparticles actually shrunk the skin cells to about 1/7 their normal size. They would get into the vacuoles of the cells, and the 13 nanometer gold nanoparticles would coat the vacuoles, and the 45 nanometers, they did something really interesting. They would actually clog the vacuoles or cause them to explode from just so much pressure just overfilling them. It would cause the cell to go through apoptosis early, and it was really hard for them to figure out how to stop that. And the cells could actually recover from the gold nanoparticles over time. They just, if it was removed, they would recover faster, but over time, through division, they would recover from the gold nanoparticles because they actually wouldn't get them out of the system. What would happen is, as they divided, the concentration would go down because it would be in 2 cells instead of 1. The top slide just shows division. This is the exposure time, and this is the cell division and recovery over time. This is for the This is for 13 nanometers, this is for the 45 nanometers. The nanometers, or I'm sorry, the cells that had the 45 nanometers actually took longer time to recover from the exposure. And this is really cool. Okay, so this, you see these little light green spots? These are actually the nanoparticles. That's like what kind of, that area right there is sort of what the cell would look like normally. And this is just coated in it. And for this is showing the rate of apoptosis. This one's for the 13 nanometer and the 45 nanometer. Let's see. 3 days exposure. So the percentages right here, the 3-day exposure, and these are the different concentrations. So higher concentration, obviously higher rate of apoptosis, higher rate of exposure, and so on. And after 6 days of exposure, the highest concentration, pretty much every single cell died or went through apoptosis. All right, so the future research is they want to discover how to keep the cells from being damaged by the gold nanoparticles. And they want to help gain a better understanding of how the nanoparticles affect various aspects of the bodily functions for future scientific and medical purposes. Right? And they're really popular in cancer research right now, because they have unique optical, electronic, and easily recognizable molecular properties when imaged. And they're really easy to detect in electron micrographs. They sort of light up. And due to their ability to enter cells so easily, and the fact they accumulate at tumor sites, through the enhanced permeability and retention effect, they offer a unique way of tracking and targeting tumor cells. And they can have tumor-targeting molecules like chemotherapy and like radioactive ions attached to them, so that they can be sent into the tumor cell and release them, like time release, and have them kill the cell. That's the tumor cell. And okay, so the gold nanoparticles in the market, and you can find them in suntan lotion, lipstick, makeup, face cream that's supposed to like tighten your skin, conditioner, yeah, hair conditioner. Like, what? Weird. And I honestly, I don't think that's a very good idea. Seeing what they do to actually do to the skin cells that they come in contact with. I think it's a bad idea. And they have a lot of potential future in cancer research, but I think we should better understand them before we start putting them in like products in the market and stuff. Yeah. Yeah. That's it. Any questions?
Reminds me a lot of when radium was first discovered.
Yeah. Yeah, that's what I'm saying. Like, if they know that gold nanoparticles mangle cancer cells, why would you think it would be a good idea to put it on your skin?
Because we're dumb.
Yeah.
We do stuff like that all the time.
What was my question? It was, so what they cause to happen to the skin cells is that they shrink because they're desiccated, like the fluids are removed from the cell, or why is that?
I think it's a little bit of that, but also the, what is it? Not the endoskeleton exoskeleton. I just forgot, I knew what it was called, the structure in the cell that supports it. It's in the cell.
There's an endoskeleton.
Endoskeleton, it actually destroys it.
Oh, that's not good.
Yeah.
So, and when it says it causes them to explode, was it just that they aren't able to remove waste, so they explode, or what was the reason?
Vacuoles, they just, for the 45 nanometer particles, they actually would clog up the vacuole and they would keep going in, and it would just, the vacuole just couldn't take it, it would just explode.
So it explode the vacuoles?
Yes.
Okay.
Apoptosis is programmed cell death.
Yeah.
So she said it caused the apoptosis.
I was just trying to think of how it died, though.
So
I was
it
thinking
would
like
get
too
too much fluids and exploded?
The cell's got mechanisms that recognize if something's out of whack, something's wrong, and then it just tells itself to essentially die. But it does it in a constructive way, so it leaves its organelles intact so that other cells can adapt those and eat them. And that's opposed to necrosis, where the cell falls apart in a destructive manner and it's not constructive at all. In fact, it's toxic.
Any more questions?
Yeah, one quick question. Why did they pick the 13 and 45 nanometer sizes? What made them target those?
They honestly didn't really say much in the paper. They didn't really give a reason. They just said that these were the two sizes that they chose.
Okay.
And were the skin cells on a person or animal?
No,
or were they...
in petri dishes.
Okay, and did they do have a control group that didn't?
Yes. They had a control group. The black line up top is actually the control group, which had normal skin cells.
I was wondering about that because it's so much different than the others.
These are the red one and the green and blue. These are different concentrations for the nanoparticles.
Any other questions? Nope. Thanks, Abigail. That was very interesting.